Okay, rationalizing the denominator. Again, when we want to do this is when we've got a radical on the bottom of a fraction, okay, in the denominator that we cannot simplify anymore. Okay, so here's your steps to rationalize the denominator. First step is to multiply the bottom by the same radical expression. Okay, and then to simplify the new expression. Okay, and I should say this is to multiply the bottom, now I'm writing in here, and the top. Okay, that's a typo on my part. Multiply the bottom and the top by the same radical expression. Okay, and then we're going to simplify. So here's what this looks like. Okay, if I've got 3 times the square root of 5, the square root of 5 cannot be simplified, can't be broken down. So I'm going to multiply this expression by the square root of 5 over the square root of 5. Okay, and the reason is this, is because if I multiply this, okay, I'm multiplying by the square root of 5 over the square root of 5. Well, anything divided by itself is 1. So really, I'm multiplying by 1. It's just written differently. Okay, again, because anything divided by itself is 1. So now what I can do is I can take 3 times the square root of 5, and that looks like this, over, and we just learned this, the square root of 5 times the square root of 5. Well, that's like the square root of 25. So what happens is the radical disappears now, and that's just 5. So now I've got 3 times the square root of 5 all over 5. Now we need to simplify the expression if we can. Let's look at the numbers, 3 and 5. Well, 3 over 5 is 3/5. That doesn't simplify. Okay, so now I need to check the radical. In my radical here, I've got no perfect square factors of 5, I've got no fraction under the radical, and I now have no radical on the bottom. So I am done. This is now simplified. Again, because I can't simplify the numbers, and the radical is completely simplified. No perfect square factors and no fraction underneath it. So again, what rationalizing a denominator means is taking the number that we have, okay, the fraction we have, and multiplying it by the denominator over itself, because that's the same as multiplying times 1. And that's a way for us to simplify it. Alright, so let's look at the next example here. Square root of 18t. Well, we can do this two ways. Okay, I can, when I got a radical on the bottom here, I can either start by rationalizing it, or I can try to simplify this first. Okay, now I'm going to start recommending that when you get something that looks like this, okay, it's not like 16 and t squared where we could just simplify this pretty easily. We're going to do more work. I'm going to start recommending us to go ahead and rationalize to start with. So I'm going to multiply this by the square root of 18t on the top and the bottom. And the reason is because that's going to give me on top, I'm going to have 2 times the square root of 18t all over, and then on the bottom, the square root of 18t times the square root of 18t is just 18t. Alright, now we need to simplify our new expression. Well, we don't have a radical on the bottom anymore, okay? So now, I need to do some simplifying. Well, the first thing I see is 2 and 18. That can simplify into 1, and I still have times the square root of 18t over, and then the 18 would simplify to 9, and I still have a t on the bottom. Okay, so basically I just simplified these out and made it 1 over 9 times the square root of 18, and then times t on the bottom. Now, square root of 18t, well, 18 has a perfect square factor, so I've got to simplify this. So I'm going to change the top to 1 times the square root of, now 18 can be broken down into the square root of 9 times the square root of 2. But I can't forget I still have this variable under here. Okay? Now, since 2 cannot be simplified anymore, I'm going to go ahead and throw the t in, okay, right afterwards, and put times the square root of t. And that's all over 9t. Alright, so now if I simplify this, I've got 1 times the square root of 9. Well, the square root of 9 is 3, so that's the same as 1 times 3, which gives me 3. And then I've got the square root of 2, which can't be simplified, the square root of t, which can't be simplified, all over 9t. Now looking again, I can still do some simplifying. I've got numbers now that I can simplify. So this breaks apart into 1 times the square root of 2, times the square root of t all over, and again, since I simplified the 3 and the 9, that's going to make it 3t on the bottom. Now the only thing I have left to do is I've got numbers that can't be simplified, I've got a radical here that can't be simplified, and a radical here that can't be simplified. So now what I need to do is take these and multiply them back together into one radical that can't be simplified. So I've got 1 times the square root of, and we're going to put these together, 2t all over 3t. Alright, and I can write it like this, or again, since I have 1 times the square root of 2t, I can just neglect the 1 and say it's the square root of 2t all over 3t. And since the t is in the square root symbol, I cannot simplify these because this one is not in a square root symbol. Okay? So again, when we have the square root of a t, that's not the same. I can't simplify out here. So either one of those two answers is correct. Alright, now I'm going to say it one more time because I know I'll throw some of us for a loop. When the t, or when the variable is underneath the square root sign, we cannot simplify. Same thing. If there was like a 4 here and a 2 here, we cannot simplify if one is underneath the square root. Okay? The only way we can simplify numbers or letters is if they're out of the square root. And let's go on to our last slide of examples here. Alright, so here we go again. We've got a square root on the bottom. Okay? Now this square root has one perfect square factor but not another. So since there's only one perfect square factor, I'm going to go ahead and just rationalize it to start with. Okay? And I'm going to multiply this by the square root of 9b. So now what this will look like is I'm going to have 3 times the square root of 2 times the square root of 9b all over, and then the square root of 9b times the square root of 9b just gives me 9b. So let's look for things to simplify so far. The 3 and the 9 can simplify into 1/3. Okay, so I'm going to have 1 times, and then the square root of 2 times the square root of 9b can be put together. Okay, we need to put it together into the square root of 18b. So we just multiply the number parts and then through the b underneath. And on the bottom then, I'm going to have, since I simplified 3 and 9, I'm going to have 3 with the b left over. Alright, and now again, I can't simplify b's or these numbers because this is under the square root, but my square root has a perfect square factor still. That's because 9 goes into 18. So now I'm going to break this apart. I'm going to just forget about the 1 because multiplying anything by 1 is just itself. So the square root of 18b, that's the square root of 9 times the square root of 2 times the square root of b all over 3b. Oh, the square root of 9, that's 3. Then the square root of 2 times the square root of b. Neither one of them have perfect square factors, so we're just going to combine them into one radical and make it the square root of 2b all over, and on the bottom we still have 3b. And now the only thing we have left to do now, again, we can't simplify the b's because one's under the square root and the other isn't, but I can simplify the 3's because they are both out of the square root. So I'm going to simplify the 3's, and now this is just going to be the square root of 2b all over b. Alright, and one last example here. So we got 16a over the square root of 6a cubed. Now 6 doesn't have a perfect square factor. A cubed does, okay, but since 6 doesn't, I'm going to go ahead and rationalize to start with. So I'm going to multiply this by the square root of 6a cubed all over the square root of 6a cubed. Now, you guys, I want you to make sure that you have this stuff written down. I'm going to go ahead and erase it because I'm kind of running together here. Okay. Give me some room. Alright. Well, 16a times the square root of 6a cubed. Since this is outside the radical and this is inside a radical, I can't multiply this stuff together, okay, and put it underneath the radical. So it's got to look like this. 16a times the square root of 6a cubed. All over, and on the bottom I'm going to have 6a cubed. And again, the reason why I couldn't multiply these together and put them underneath one radical and have one big radical is because this is not under a square root sign. If this was the square root of 16a, then I could multiply 16 times 6 and a times a cubed and put them under one radical. But since this is not under a square root sign, I cannot do that. Alright, well, I got a check here. I'm going to do some simplifying to start with on the outside here. Okay, so 16 and 6, if I divide each of those by 2, then I'm going to get 8 over 3. And then a and a cubed can simplify. This is going to knock itself out, and this is going to be a squared. So if I rewrite that on top, I'm left with 8 times the square root of 6a cubed all over, and on the bottom I've got 3a squared. So now if I look at this, on the outside I've got an 8 and a 3. Those can't simplify, and I've got no more variables to simplify. So the last thing I need to look for now is are there any perfect square factors underneath the radical? And we talked about this. We can break any odd exponent apart and so that it includes an even exponent that we can pull out. So 8 is going to stay. I'm going to have the square root of 6 because there's no perfect square factors there. And the square root of a cubed, I'm going to break apart into the square root of a squared times the square root of a. I'm going to put that all over 3a squared. Alright, well on top here, 8 doesn't simplify. I'm looking for things that do simplify here. Well, a squared simplifies to a. So I was able to simplify that. Okay, and then I've got two things under a radical that cannot be simplified anymore. So now, since neither one of these can be simplified, I'm going to take them and combine them into one radical and make it the square root of 6a. All over, the bottom stays untouched, 3a squared. Now I've got a radical that cannot be simplified anymore. Okay, so the only simplifying I can do now is anything outside here. Well, 8 and 3 can't simplify, but a and a squared can. So now what I have left on top is 8 times the square root of 6a all over 3 times a. And again, our checks here. 8, nothing outside can simplify because 8 and 3 don't simplify, and there's no variables. And on the inside of the radical, there's no perfect square factor for 6, no perfect square factor for a, so I am done. And that's as simplified as I can make that. Alright, and that's your lesson on rationalizing denominators. Now this is pretty complex stuff, especially when we throw in the variables. So if you have any questions, please make sure you ask them. And good luck on the homework.